Welcome, everybody. Welcome to our web window for this month from ARC Advisory Group. My name is David Humphrey, and I'm here to report on some findings of some research that we've conducted in the area of, in general terms, the future of visualization in industrial applications. All right. Again, thanks to those who have just come in for joining us. We're going to spend about a half an hour today talking about some research that we did on the future of visualization in industrial applications. And I'll talk about two things, HMI trends in general, and I'm using HMI, that stands for human machine interface. I'm using that as a synonym for visualization. So I might say HMI, or I might say visualization. And then I want to talk about a key element of visualization that has nothing to do with displaying data. It's actually deploying the software. I'm going to talk about new deployment models because that is a big driving factor in how visualization will work in the factory and in the plant in the future. Let's take a look at a classic automation architecture. These have looked the same more or less for at least 25, maybe 30 years. This shows a typical line. This could be, let's see, I see a pulper, I see a mixer, I see a kettle, there's some bottle washing and some filling. So it looks like a juice making line. I don't know exactly, but that's what it looks like to me, with some packaging on it as well. Typically, we equip each machine, each station with its own PLC and its own operator panel so that somebody can stand there, can set parameters on the machine, operate it, can read values from the machine, can monitor to make sure that the process is proceeding smoothly, and can quickly identify faults that are reported locally if anything happens. And then some of the equipment might be delivered with these IPCs. These are industrial PLCs that I've indicated here, just sort of randomly, that might use some PC-based visualization software that gathers data, stores it in a data bank, a database, or might extract that data from a database to display it on the screen. At the very left-hand side, that looks to me like a line PC. It's sort of the master PC that gathers information from all of the machines along the line and stores it, visualizes it, allows complete line maintenance and operation. This is classic. This sort of architecture results from the fact that each of these pieces of equipment might be delivered by a different equipment provider, a different company, maybe located in a completely different country. So the end user here, the juice maker, when he plans his new line, he buys the best of breed equipment from companies in Germany, companies in Italy, and they build their equipment. They put their PLC on it at the factory to test it, and then they send it on a truck, and it gets reassembled at the customer site, and everything is then connected and integrated. So this is the classic architecture that we've been used to for many years. HMI, when I refer to it, can be one of two things, really. If I just go back, it's those operator panels, which are a closed device that is configured externally and then connects usually directly to a PLC and is only associated with that PLC. And then there's the PCs that I mentioned that are on the line and can exchange data between PCs and between PLCs. An operator panel is a closed system with a configured visualization. An IPC is an open platform. So today, a typical product would be Factory Talk from Rockwell or WinCC from Siemens. These typical HMI applications that have been around for a long time. What's happening with them? What are the trends? Well, actually, they're mature. There's not much going on in the area of HMI and development because these tools have been developed really since the 1990s, and they're highly mature. So we could end the presentation and say there's nothing new in HMI, but that would be cheating you. Let's talk a little bit more, because if I look into the future, I do expect certain developments. I don't expect a lot of new features to be added. HMI has everything that we need pretty much. It's fairly easy to use software. What I do expect, though, is that the tools to gradually become more sophisticated by adding functionality that starts to infringe in the areas of other applications. If I go back 30 years, we didn't really have very much industry software. Then HMI started to appear running on PCs. Then MES started to appear also running on PCs. And since then, we've added a huge amount of software for managing maintenance, for managing quality assurance. There's a lot more software as a part of the automation solution that we had in the past. And at some point, this software functionality is going to start to overlap. So question, does every application that shows data need to have its own built-in HMI? Or wouldn't it make sense, for example, to have a single source of visualization tools that other applications can tap into and use? I'll talk a little bit more about that in a little bit. Some of the features that I expect to see is more sophisticated data visualization. And what I mean by that is currently a machine will have a fixed program that shows data, and the operator can switch screens. Usually we try to limit what the operator can do because we don't want him standing in front of the screen the whole day long, looking at pictures and numbers. We want him thinking and understanding and observing the machine, and only using the screen really to intervene when something is necessary. But there's an idea that we get from the IT world that we can empower our workers by putting tools into their hands where they can visualize. I'm using my hands right now, if you can see my screen, where they can visualize whole, just with their hand movements, whole swaths of data and plot them as they're going through the machine, and try to spot trends and try to interact almost physically with the data to understand what's happening. That's kind of a fantasy, but it's not a bad idea to trust your operators, to train your operators well, and to put more power, more tools in their hands so that they can take care of problems themselves as they occur, and using data to support the decisions wherever possible. There's one area that I looked at in the past 2 years that's starting to come to our industry. It's right in the middle of the screen. It's called industrial data ops. It's a concept, like most of these things, borrowed from the IT world. Data ops is a concept in the IT world where I pre-cleanse data, where I use an application to sort data. I might convert data to make it convert it into a standard format so the data can be comparable between different data sets. We like to call it data democratization, because it takes complex, disparate data that is difficult. It's there, but it can't really be used because it's too complicated for the average person in the plant. What you need is a data scientist to come in and to do laboratory experiments on the data to turn them into some sort of form that they're actually useful. Well, that's what these tools do. They're called data ops in the IT world, and we're starting to call them industrial data ops in the industrial world. It's a very new science. There's some products coming out. Cognite in Norway is a leading company in this area with some really interesting solutions. Also, Hitachi Vantara, based in the US, is working in this space. And the idea, like I said, is to empower people in the factory, in the plant, by making data more accessible, easier to use, and therefore more valuable for a wide swath of plant personnel, and not just for the specialists. Yeah, and then another trend that we expect to see is HMI software can go only so far with the development of tools that allow you to draw 3D diagrams with your data and do really sophisticated displays of data in order to help make data make sense. What we're starting to see a little bit, and what I expect to see, is instead of these advanced data visualization tools being a part of WinCC or one of the other industrial products, to see that this space being discovered by a number of third-party IT companies that don't really dabble in industry right now, but what we'll discover are starting to discover our space as being interesting and are offering their tools that integrate, for example, with a WinCC or integrate with FactoryTalk. And what they do is they provide that that best of breed solution that offers more functionality than you're typically going to find in an industrial data package. I mentioned briefly before the concept of a visualization platform. This is a little bit early, but it fits together well with some of the new deployment models that I'll talk about towards the end of this presentation, maybe in about 5 or 10 minutes. The idea of a visualization platform, like I said, is a central repository for all of the visualization elements, all the pictures, all of the scatter plots, all of the diagram potentials, bars, columns, and things like that, the stuff that you have in Microsoft Excel. But all of that being located in a single server so that other applications like maintenance management, for example, can tap into that and display recent maintenance, recent performance data about a machine, rather than those tools being a part of the maintenance management software. This will require more standards so that different applications can tap into elements that are standardized so we know how they work. But it would be a lot more efficient and would fit very, very nicely with the idea of a containerized, Docker containerized, virtualized deployment of software in the future. I put down a couple of examples of where I see some of the activity in this area. I mentioned Aviva, which belongs to Schneider completely now. Rockwell Automation is also moving in this area. And there's another really interesting company that's based of all places in Silicon Valley in California called Inductive Automation. It's not exactly known for that area for producing industrial software. But that's a company, as a vendor that's very close to the IT world and produces a number of products that that support some of these sophisticated concepts. I couldn't talk about visualization if I didn't talk about some of the cool technologies, especially augmented reality. There's also virtual reality. Virtual reality is almost like the metasphere, where I can move about in an industrial space that is simulated on the screen. I'm not going to talk about that today. That's more common in the process industries for training purposes. Let's stick today just to augmented reality. Augmented reality is goggles. It doesn't have to always be goggles, but the examples that you see typically involve the technology to display information somewhere between the person, the operator, and whatever he or she is working on. There could be a machine that's being maintained, or in the photo you see here from Siemens, could be a workpiece that is being simulated on a workbench. And again, augmented reality is itself, it's not an application, it's a technology. What it does is it enhances existing applications by making data available and visualizing data in ways that we typically don't do today. We typically put it on a screen somewhere, which is like a little TV set in front of your machine, and that's it. So, but AR has been around for a number of years. I just don't see a lot of movement in AR. What I do see is a heck of a lot of really cool demos. And that's what I mean here by proof and concept stage. It seems like AR is always being tested and shown. Slick demo movies are being created to show the potential what AR could do. But I don't see it really in use a lot in practical applications. And I think the reason is that the biggest barrier is the fact that the technology requires that information from multiple sources be integrated. So the glasses like this guy here is the output device. The technology to make data appear in those glasses, it's not difficult. It's been done. It's been solved. But what data do I use? Where does it come from? Does it come wirelessly? Does he have a cable Does it come from a phone or a tablet he's carrying? Does the machine itself have some sort of transmitter that transmits only in near space to a person when he approaches and gives them the relevant, correct data from that machine only? Am I tapping into a database? Am I tapping into HMI? Am I tapping into the maintenance software? There's so many different ways of putting together for each machine the sources of the data that there's no common way. There's no good best practice yet available. And I think that's what's keeping or holding up the wide acceptance of augmented reality. But once we get that far, the benefits are really better plant-wide operations and maintenance everywhere, in every aspect. There's so many applications where AR can enhance very, very subtly applications I mentioned here. Obviously, HMI and maintenance, quality assurance, PLM. The guy in the picture looks like he's prototyping. So that would be actually in the area of product design, which would fall under PLM. I looked at some of the companies that are currently integrating AR into their applications, and I came across the top three automation software vendors today. Again, Aviva, which of course belongs to Schneider, Rockwell Automation, which partners very closely with PTC and has this product which is really cool called Vuforia, and then Siemens also offers a maintenance AR enhanced application called Assist AR. All right, let's take a look at some user trends. That was the technology and the functionality. We expect HMI software to become more collaborative. In other words, it'll borrow what I call the framework concept of multi-user browser-based tools. You see this a lot with some control systems from Honeywell, from Siemens, where they don't actually have software that you install on your machine. You use a simple browser, and the actual program, the actual configuration you're working on is in the cloud somewhere, and it's being worked on by several people at once, maybe even different parties around the world as a total automation solution is gradually developed. This is a little more common in the process industries because of the size of the projects, but it will likely come to our space as well in the discrete automation. Multi-touch panels, we know them from a lot of other applications in the industry. They're available. Companies like Beckhoff have great panels that understand common gestures, multi-touch gestures. As we allow and empower our operators to manage their data better, there will be more call for multi-touch panels that allow the interaction with the panel rather than pressing F buttons, F1, F2, F3. A multi-touch touch screen that understands gestures makes it a lot easier to manipulate data and more of a proper human-machine interaction. I mentioned industrial data ops already. This obviously affects the user because it's going to change drastically the way users interact and receive data and are given access to data that they can understand and make quick use of without having to call the doctor. And finally, I mentioned a trend that's been going around for a few years, but it's developing, it's getting more popular. That's low-code, no-code tools. This is another empowering tool that lets users using with very few skills create their own sort of mini application to display and manipulate data for their purposes, for their particular application, maybe for today, and then let's change it again in a week from now. But no code means that they configure, so they might push objects around a screen. Low code means that they write maybe a little bit of code, but it's very simple, very easy to understand, very easy to change. I want to talk about the second trend. That was pretty much the HMI trends that we see, but none of these trends are going to be possible without understanding the new deployment models that are starting to hit the industrial world. To understand these things, I have to ask my brother-in-law. My brother-in-law works in IT, and he works for one of the big banks, and he's constantly doing rollouts and deployments across hundreds or thousands of devices, PCs and servers, and handheld devices and phones. The IT world has learned years ago how to properly manage devices and software, to consider everything valuable assets, and to create a history of how these objects have been handled and updated and where they've been located. We're just starting to see some of that IT way of working with things in the plant now that our plants are getting to be more and more IT-like. Just an example, the second line down, application architecture. In the past, there was always a big piece of software. I mentioned visualization software like WinCC. It's a big application. It comes on a CD. You install it on your PC, and you use whatever functions that you need from it. You might not need 90% of the functions, but you still get them. They're still there because it's monolithic software. And what we're seeing now is a trend for the vendors to break up these monolithic applications into modules, so that each module is a particular functionality, a particular aspect of visualization or of MES. And as a user, I only implement those modules, those aspects that I need. The smaller they become, the more portable, the smaller footprint, the more agile, the more efficient they are. And what we're moving basically is from monolithic to microservices. The idea of a visualization server could be something like a microservice. It's where all the data, all the pictures are stored, and anybody that wants to use them, any other application can tap into them. Excuse me. One of the most important things that we're seeing is the application deployment in the next line, going from physical, which means putting onto the machine, onto the PC that's right there at the manufacturing production machine or packaging machine, and gradually moving to this idea of using virtualization to deploy software that is not really on the machine anymore. It's located on a consolidated form somewhere in the factory. Let's take a look where. This is our diagram of our juice line again. Remember the PLCs and the PCs that we had along the line, and the operator panels. This is the next iteration of development that takes on that non-critical, I call it level 2 to 3 applications, like what we've been talking about, MES or HMI, taking it off the machines, taking all that computer hardware off the plant floor where it really doesn't belong in the first place, and consolidating these applications on a server. The server is indicated as a cloud, but let's call it a plant cloud or a plant server. It's in the building, it's on premises. Our networks are fast enough. We don't need faster networks than 10 gigabyte Ethernet to connect everything together. What we do need is good people in the IT room where this server is installed, where it's maintained, where it's backed up, where it might even be built up in redundancy to make sure that the data are always available. The virtualization concept allows me to put as many applications as I want on a single server. Let's see if I have the diagram. There, it's one slide back. If you look on the right-hand side, the diagram at the lower right-hand corner basically shows the concept of virtualization. In this case, this is the Docker concept. The Docker itself is the container, and it contains as many applications as you want that run in a controlled environment, and that runs on top of the host operating system. What I don't have a diagram for here is the virtual machine, and the only difference really is that in the virtual machine, each application runs on top of its own operating system. So if you see application A through F there would also be guest operating system A through F. That creates a lot of unnecessary software, a big footprint for all of the applications. A Docker configuration like this is a lot more efficiency, a lot more efficient because of the smaller footprint. The virtual machine concept is still useful and it's still widely used, actually, because it allows me to have any of these applications here could be legacy. It could be software that was written in the 1990s for which there is no support anymore, that only can run on a much older version of Windows. It could be MS-DOS for that matter. That's one of the advantages of packing up the application with its own operating system if it's old legacy software. And believe me, plants today are full of old legacy software that people don't know what to do with because you can't update it. So I mentioned the two concepts and how they go together. There's trends happening in HMI, but there's also trends happening in the way we deploy HMI, and not just HMI, but all plant software. And what I found from the research we've done is that the two go together. You can't talk about one concept of new modular, full-featured, advanced visualization tool HMI software without discussing the new architecture that you need to have it run on to take all advantage of all of that. So visualization platforms can happen, but they need to be containerized so that other applications can access them. Virtual deployment models are starting to come out. We're seeing more and more companies use this for non-time critical software, resulting in much greater efficiency of application software management. What I mentioned at the beginning was that AR, but I put the point out at the top there, it belongs at the bottom, that AR as a visualization technology that's been around for a while will continue to advance, but it'll be slowed down by the fact that the integration is so difficult. So what it comes down to is HMI in visualization is about making workers' jobs easier. This here is a photo of the Mercedes plant in Sindelfingen in Germany. And what's interesting about this is what you see there is not an operator panel. It's not an industrial PC. It's a big television set. That's not an industrialized device at all. It's what it is big. It's not fancy. I don't see any sophisticated data visualization tools. I don't see any 3D. I don't even see a single bar chart on there. But what it's doing is it's displaying the information that the workers you see need at that moment in time. It's controlled not by HMI software running on a PC. It's controlled by a very sophisticated information management that was developed by Mercedes-Benz in-house. They didn't take an off-the-shelf product. They went out and did it themselves. And that big screen television there is nothing more than a client that is simply displaying what the master application it's decided needs to be displayed at that moment. I've been to this plant. It's very, very interesting to see how humans work together with information. What you don't see in this plant is a lot of robots replacing people. Instead, Mercedes in this exact same plant, I remember I was there about 35 years ago, had a lot of robots trying to replace the humans with sophisticated technology. What you see today instead is fewer robots, more people working in a very comfortable environment, constantly supported by information that is supplied to them just in time, just in the location where they need it, so they can get the job done on a station-by-station basis. Very, very interesting stuff. And with that, I would like to close, and I'd be happy to take any questions.